Hello class. Today what we are going to look at is inequalities in a single triangle. Okay, so all of the stuff we're looking at is going to take place in the same triangle. Now, got a couple of theorems here. We're just going to jump right into those. First theorem, the triangle longer side theorem. What this says is that if one side of a triangle is longer than another side, then the angle opposite the long side is larger than the angle opposite the shorter side. Okay, so what that means that since AB has a length of 8 and BC has a length of 5, then the angle opposite AB, angle C, is going to be larger than the angle opposite BC, angle A. So angle C has a measure larger than the measure of angle A because the side opposite that is larger. All right? Then we have the triangle larger angle theorem, which says the exact opposite. All right? This says that if one angle of a triangle is larger than another angle, then the side opposite the larger angle is longer than the side opposite the smaller angle. Okay, so since angle A measures 50 degrees, so that's larger than angle C, which measures 30 degrees, then the side opposite angle A, BC, is longer than the side opposite angle C. So BC is longer than BA. All right? And that's easy enough. Bigger angle, bigger side. Bigger side, bigger angle. Basically all it is. Real simple. All right. Now, next thing we're going to look at is the triangle inequality theorem. What this says is that the sum of the lengths of any two triangles must be greater than the length of this third side. And we've got these three pictures here showing this. All right. So if we have one side that measures 5 units, the other two sides measure 4 and 2. 4 plus 2 is 6. That's bigger than 5. And so they meet together and you get a triangle. If, however, those other two sides were 2 and 2, there was only 4. That means that no matter where I rotate these two sides, they're not going to reach. Okay? So we're going to have this gap in between them. They're not long enough. So it's no good. If they're 3 and 2, so they exactly add up to 5, they are going to reach, but they're going to reach right here on the 5. And so they don't make a triangle, they're just going to lay on top of each other and make a line, and that's no good. So it's very important that the sum of any two sides is greater than the length of the third side. Easiest way to look at this, the two short sides will add up to more than the long side. It's basically how it works. All right? So let's take a look at this. Open this up, take a look at some examples. So here we go, 1 and 2. What we want to do here is list the sides of the triangle from shortest to longest. All right. So from shortest to longest, well, it's going to be looking at the triangle longest side theorem. So we know that the side opposite the largest angle is going to say, whoa, we want to match the sides up. We're given the angles, so we're looking at the triangle larger angle theorem. So the side opposite the largest angle is going to be longer than the side opposite the shorter angle. So we need to know what the angles are, because we have no clue what the sides are. But we can still do this. Well, we've got 87, which is bigger than 21. We're missing an angle. So we've got to figure out that angle. Well, that's easy enough because we know triangle sum theorem, all of the angles add up to 180 degrees. So we're just going to real quickly, 87 plus 21, which equals 9 and 109, and 180 minus 109 is going to equal 71. So that means angle B is 71 degrees. So what we're going to do first is put all of our angles in order. 21 is less than 71 is less than 87. So to put our sides in order from shortest to longest, the side opposite 21 degrees is going to go first, side AB. The side opposite 71 degrees is going to go next, side AC. And the side opposite 87 goes last, side BC. And that is the answer. All right. And that's all there is to it. So that's pretty simple. All right. Number 2, however, gets a little bit trickier because now I don't know what the angles are. I'm just given some variables, so all x, right? So you've actually got 2 options here. You could take all 3 of these, add them up to 180, solve for x, plug those back in to find out what the measure of each of these sides are. Or we could just compare them like they are. I don't know what x is, but I know that 2x's is more than 1x, right? So I know that I'm going to have x is less than 2x. And I also know that whatever x is, if I subtract 4 from it, it's going to be smaller than what it started. So I also know that x minus 4 is less than x. And so I could just put those in order like that. Or we could add them all up to 180, solve for x, plug it back in, and compare it that way. All right. But this is a lot easier, it's a lot faster, and so we can just do it like that. So the side opposite, my smallest side, goes first, because it's from shortest to longest. So this is my smallest side, or smallest angle, so the smallest side is opposite that, PQ. So side PQ comes first. Next would be the side opposite the x degrees. So there's x, side opposite that would be PR. So segment PR. And then finally we have 2x, and the side opposite the 2x degrees is segment QR. Just like that. And that is, and that's pretty easy. So let's take a look at 3 and 4. And 3 and 4, they're giving us the sides, and they want us to list the angles. So we're doing it the exact same thing, just in the opposite direction. So first, we're going to take the sides and put those in order. All right, so we have still smallest to largest. So 16 is less than 18 is less than 30. And then the angle opposite side LM is angle N. So angle N. Next we have 18. The angle opposite the 18 units long side is angle L. So angle L. Make sure your angle and your L look different. All right. And then we have the 30, the side that's units 30 long, whatever that is, 30 inches, 30 whatever. And the opposite of that would be angle M. Angle M. And there it is. That's all it is. You put the sides in order, and then you just match that up with the angles opposite those sides. All right. Okay, so let's take a look at number 4. And you're going to do the same thing. It's got x's again. And here there is no way to solve for x. You have no idea, because there's no rule that says the sides add up to anything. We don't know. However, I do know that 5x's is less than 8x's, right? So I know that 5x and 5x. So these two are the same length. I've apparently got an isosceles triangle. But 5x is less than 8x. So if these two are the same length, that means that these angles are the same, because that's the base angles there, right? So it really doesn't matter which one we put first. We know that F and D are going to go before E. So angle D, angle F, those are the same length, so list them first, and then angle E. And it doesn't matter if it's angle D, then angle F, or angle F, and then angle D, because they're the same size. So there it is. So there's our answer to that one. All right, that's pretty easy stuff. All we're doing is put them in order. And then it's the one opposite. All right? The side opposite the angle opposite the side. Not bad. Okay, let's take a look at these. What do we have here? All right. In exercise 5 through 8, we want to know, is it possible to construct a triangle with the given lengths? And if not, explain why not. All right. So, I don't know, you think, well, you've got 3 sides, of course it'll work, because that's what makes a triangle. However, remember, those lengths might be too short to make the triangle work. Right? If they're not going to be long enough to touch each other, then it's no good. And what that basically amounted to was that the smallest 2 sides have to be more than the largest 2 sides. Okay? It's basically what that amounts to. So all we're going to do, we're going to take the two smallest numbers, so that would be 3 and 12, and they have to add up to more than the largest number. So 3 plus 12 has to be greater than 17. Well, 3 plus 12 is 15, which is, nope, not greater than 17. It doesn't work. And so, no. Explain why not? Because 15 is less than 17. It's no good. So if we did this, they wouldn't touch. They'd be out here not touching, not making triangle. Okay, so number 6. 5 and 21 and 16. We're going to take the two smallest sides, so that would be the 5 and the 16, and those need to add up to be more than the largest side, the 21. So 5 plus 16 is greater than 21. That's what we need to test, right? So 5 plus 16 is 21, which is greater than 21. No, it's not. It is not greater than 21. So what this means is that we have this triangle and they're going to touch, but that just gives us a line. We need them to be shorter so they stick out like that. They're longer so it's not big enough. So it is not greater than 21, so we're going to say no, explain, 21 is not greater than 21. It is equal to 21, but it is not greater than 21. And it has to be greater than the longest side. So that's no good, because 21 is not greater than 21. Okay, so let's try number 7. Let's see here. We pick our two smallest sides, 5 and 7. Add those up, and those need to be greater than the long side, 8. So 5 plus 7 is greater than 8. Well, 5 plus 7, that's 12, which is greater than 8. That checks out. It works. And so the answer here is yes, this could be a triangle. Okay, let's try number 8. Its two smallest sides would be 3 and 10. So 10 plus 3 is, we want it to be greater than 11. Well, 10 plus 3 is 13, and sure enough, that is greater than 11. So again, this one checks out, and this will work to make a triangle. All right. So remember, the two small sides have to add up to more than the longest side. Not equal to, not greater than or equal to, greater than. Has to be greater than the longest side. Okay, so let's see. Last two examples here. Describe the possible lengths of the third side of a triangle given the lengths of the other two sides. Okay, so this time it's going to be using the same theorem as this. Still looking at that triangle inequality theorem that says any two sides has to add up to more than the last side. All right. So there's two things that could happen here. We could have a triangle where we have 5 and 12 and x is this longest side. Or we could have a triangle where we have 5 and x and 12 is the longest side, right? 5 can't be the longest side because 12 is obviously more than 5. So we're going to have one of these two cases. Okay, it doesn't matter if x is shorter than 5 or if 5 is more than x. 5 is less than x. It doesn't matter. All that matters is which one is the longest side. So let's take this case first. If this is the case, then 5 plus 12, our two short sides, have to be more, add up to more than whatever x is. So 5 plus 12 is 17, and so 17 is greater than x. Okay. Over here, whatever these two are, have to add up to more than 12. So 5 plus x has to be greater than 12, because they have to add up to more than the longest side. So here we subtract 5 from both sides, and we end up with x is greater than 7. All right. So our answer, we're going to take a 7 inches, that's the smallest it could be, is less than x, which is less than our largest answer, which is 17 inches. So that third side has to be somewhere between 7 and 17 inches long. Now, if you'll notice, all we did, actually, is we took the two numbers they gave us, we added them up, that's the biggest it could be, and then we subtracted them, and that's the smallest it could be. That's it. You add them up, there's your answer, you subtract them, there's your other answer. That's it. You add, you subtract. And it's got to go somewhere in between those. So let's take a look at number 10. We have one that's 2 feet, one that's 40 inches. All right. So either we have one where we have, oh, wait. We've got feet in inches. We can't add feet to inches. That's no good. We got to change them to the same thing, don't we? So easier to change feet to inches. So we just take this. This is 2 times 12, which equals 24 inches. So there we go. 12 inches to a foot. So either we have 24 inches, 40 inches, and then something longer than that right here, or we have, let's see, 24 is shorter than 40, so we have 24 and whatever x is, and then 40 is longer, right? But as we saw before, all we're going to do is we're either going to add them or we're going to subtract them. Actually, we're going to do both. We're going to add them and subtract them. So 24 plus 40 is going to be greater than x, so that would be 64 is greater than x. And over here, we're going to subtract them. So 40 minus 20, 40 minus 20 is going to be less than x. So 40, sorry, not 20, it's 24. 24. And 40 minus 24 is 16. And so we have 16 inches is the minimum length that this other side could have. 16 inches is less than x, which is less than 64 inches. That's it. So, inequalities between triangles. The longest side is opposite the longest angle. The shortest side is opposite the shortest angle. And vice versa. The shortest angle is opposite the shortest side. The longest angle is opposite the longest side. And the two smallest sides of a triangle have to add up to be longer than the longest side of a triangle. All right? The two smallest sides add up to be more than the longest side. And if they give you two sides of a triangle, the third side has to be less than the sum, more than the difference. All right? You just add them, you subtract them, and x is going to go in between those two numbers. And that's it. So, this lesson, pretty simple stuff, really. I hope you found that useful, and I will see you next time.